about the weekend, Alexis. Can we do math? Thank you. Thanks.
All right. How's it going?
Splendid.
A reminder, today's Tuesday. What happens on Thursday? Chapter 7 test. As a reminder, also next week on, I guess it would be Wednesday, what happens? That's the retake day. If you opt to do the retake versus the test double. I would hope that you could let me know by Friday this week if you're going to do one of the retakes. Just send me an email. I just need a little bit of time to get everything together for that day. Ben?
So if we do really good on this test, can you boost this test grade?
Right. Your double test score is going to come from your highest of the 4 tests we've taken this year, including this one to be taken on Thursday.
I was just asking if you were doing this test too.
Yes, absolutely. I haven't put any of the doubles in, just FYI. I will do that immediately as soon as I'm finished graded, or once I have Chapter 7 test graded, I'll put the doubles in. That'll, even if you have opted to do the retake just so you can kind of see what's going on, I'll just take it out after. I'll do something. I'll use the doubled column to put your retake score in, and then exempt out your other ones so you can still. I haven't figured out exactly the easiest way to do that with the retake. But I was put in your double even if you're planning on doing the retake and just figure it out later, just so you can see what it is. Okay. I did the drops earlier this week, so you might have seen your scores change a little bit for unexplained reason. So I put in the drops for the low homework score and low quiz score. So those went in already. Everybody cool with that?
Yes, thank you for your services, Mr.
Hefner?
So, are we not going to have a homework quiz for this section?
We are. We're going to do it today.
Oh, okay.
So you beat me to the punch. But we're guys going to do with questions first and then do the homework quiz to end. But yes, we're going to do that still.
Okay.
But the computer will take care of the drop automatically.
Okay.
New scores coming in won't affect that. Woody?
Okay, so for the test, are we going to have a half sheet paper?
Yeah, so if you looked at the review, I didn't give you a lot on the review. It's the same as deal would be for the test. So I think a half sheet is reasonable. So again, you can bring a half sheet of paper, front, back, handwritten for the test on Thursday. Totally okay.
Thank you. That's I would love it.
You're welcome. Okay. Let's get going here then on today. Yes?
Oh, Mr. Cooler, we're having a final exam, correct?
There will be a final for this class.
Semester 2 only, correct?
It'll be semester 2 only.
All right.
And I'll get my plan for Monday of next week is to spend that time kind of talking about the exam format, what it'll look like, and going into detail there. I don't want to get too ahead of our skis with Chapter 7 test, still kind of new. So I'll have that for you guys next week to talk about. All right. So questions from Chapter 7 stuffs. Joe.
Do you mind doing number 1 from homework 5? This is like an easy question, but I just want you to go through the steps of expanding again, if that's all right.
Sure. So, if you remember, there are 3 properties that we use for expanding and condensing. So those 3 properties are the product, the quotient, and the power properties. When we're doing expanding, the order that we go is we go quotient, reverse order. So we do power first, and then product, and last would be quotient. So on homework 5, number 1, it's asking to expand. So first thing I'd be doing is looking for a quotient property. So to the quotient property, or for expanding, I'm looking at what's going on inside the logarithm. And I see no division, so there's no quotient property to do. Okay.
So product
Next up is the product property. I do see multiplication going on.
Yeah.
So what the product property would allow me to do is to rewrite this as the sum of two logarithms, the log of 11 plus the log of, or the log of 6 plus the log of 11. And then I would look for power properties, but now instead I'm going to be looking inside each of these two logarithms, but neither one of those have an exponent in there, right? So I'm done.
Oh, that's it.
What?
Could you just write it as log 66?
Well, no, because you didn't expand anything.
Oh, okay.
Could you do number 6 as well on the expanding, because that one has a quotient and an exponent?
Yeah, so there's really like a second set of parentheses here that they didn't write.
Okay.
I stole this worksheet from the internet.
Okay.
So what I would do here first is either, because that set of parentheses around the fraction, I either have to go out of order, or I could simplify the stuff inside the logarithm to get rid of the fraction. I think that's what I would do.
Okay.
So if you remember from last chapter, if I have the exponent of a fraction, that exponent applies to both the top and bottom of the fraction.
So basically, that's only if the exponent's outside of the parentheses?
Correct.
So when it's outside, we apply it to the numerator and the denominator?
Yeah, so if you have like this, the exponent goes to both places.
Right.
If you had this,
Stays at the 6.
it just stays with the 6.
Okay, cool. Thank you.
Okay. So, again, we go quotient first. I do see division going on. So the quotient property says I should write this as the log of the numerator minus log of the denominator. So there's that. And then I look inside each of those logs and I see an exponent. So I do have power properties that I can do in each one of them. The power property moves the exponent to the coefficient. So I would have 6 log 6 minus 6 log 5. And that's all.
Oh, okay.
So this is my final answer right here.
Is it possible to have a quotient and a product property? Like, can you use all 3 properties in one problem?
Oh, sure. So like if you had log of x squared y over z to the third,
Oh, yeah, now you can, okay. I see.
you could definitely use all 3 there, right?
Yeah.
So we do quotient first, numerator minus denominator, product second, and then powers last.
Okay, that's not bad at all. You just gotta memorize the steps.
You just got to know the order.
Yeah, that's fine.
And those properties are things, and the order of things I would put on my equation sheet
Yeah.
for the test, right? So I don't have to even really memorize them. Hal,
Can you do 14?
14 on this sheet. Okay. Nice. So 14 is very easy. It's just written in kind of a weird way. So this log 6 over 3 is the same thing as like 1/3 times log 6, right? Notice that the divided by 3 is outside of the logarithm, it's not inside. You guys see that? So the way to think about it really is you want to think it as 1/3 times log 6. So this is a condensing problem. So we need to use the opposite order for the properties. So we need to do power, product, then quotient. And when doing the condensing problems, instead of looking at what's going on inside the logarithm, we look at what's going on outside the logarithm, because we're doing the opposite direction. So for a power property, we're looking for things, or for coefficients, and we see that we have one. So the power property allows me to move that coefficient to the exponent inside the logarithm. Next thing I do is look for product properties, but there's no addition going on outside the logarithm, so there's no power property to do. And then I'd look for a quotient property last, but there's no subtraction going on outside the logarithm, so there's nothing to do there. So this would be my final answer, although it's not my best answer. You guys should recognize an exponent of 1/3 as a radical, right? That's the same thing as a cube root. And this would really be the best way of writing that answer. Joe?
So, like whenever we see addition, do we assume that it's the product property?
Yeah, so when you're doing condensing, if you see addition outside of the logarithms,
That's product.
that's a product
And
property.
subtraction's quotient.
Yeah, so like that would be a quotient
And then the exponent is just like straightforward.
is a coefficient, right?
Yeah.
So like,
Oh, it's a coefficient before the logarithm.
yeah, so something like that is a product.
Oh, so like you said, it's like backwards.
It's exactly backwards.
Like literally.
Yes.
Okay, cool.
Yes. Cal,
What's the answer to number 13?
log of 3/8.
Oh, really? Okay. I just get so confused. I'm so confused by like the properties. Like I'm really confused on like where to start by using that.
Okay. So the order is the key.
Yeah, like I'm.
And then, like we had said, so expanding, you go quotient, product, power. Condensing, we're going to go power, product, quotient. And when we're expanding, you're looking inside the logarithm. That'll tell you which property you're using, or what properties you can use. And for condensing, you're looking outside the logarithm. And that'll tell you which property you can use.
So is it quotient, product, property?
Quotient, product, power.
Oh, power. Okay, can you hold that there?
Yep. Woody?
Number 9 on the
Sure. One moment. I think we're still writing stuff here. Or we have some people still writing things here.
Okay, I'm good.
Well, it's also in the content library
I
too,
know.
right? You guys know if you sync, you can see it on your screen too, and you just copy it. I'm just saying. You know. I get it. You know. And it's in the notes. You said 9, Woody? So this is a radioactive decay problem, right? Because we're talking about radioactive elements and their half-lives. So the model I'm going to use, this is the review, is this A equals PERT model. And there's a couple of tricky things going on here. So my P is this initial amount. my r is coming from the half. So r should be a half, because it's half-life. And because this is radioactive decay, the r also is negative. So it's negative a half, because it's half-life is the half part, but it's negative because it's decay. Everybody okay there? But this is a rate like per 800 years. So this is a little tricky. So when we write our model, A equals P, which is 50, e to the r, which is negative 0.5 t. But t is in the number of half-lives. It's not per year. So if I put in 1 for t, that's the equivalent of 800 years. If I put in 2 for t, that's equivalent of 1,600 years. Because the way we've written this function is that t is a half-life, not a year. Is everybody okay with that? So what I need to do here for part B is we're given a time in years. I'm just going to convert that into half-lives. So if I take 7,000 and divide it by 800, that's going to give me the number of half-lives that occur in 7,000 years. And that's the number that I'm going to plug in for t. When I type this into my calculator. Are we okay with that idea? God bless you.
Mr. Clute, can I use the restroom, please?
Absolutely.
Thanks.
Yep. What, are you still good? Yeah. Okay. And then to do the last piece here, I'm going to do this graphically. So what I'm going to do is in one of my y equals, I'm going to graph my model. So 50 times e to the negative 0.5 times x. And then my other model, or my other equation, I'm going to have 1, what I want it to equal. Okay? Now, before I graph this and find the intersection, I'm going to set my window because probably if I just hit graph, I won't be able to see anything. So remember, x in our problem is the number of half-lives. I know in just under 9 half-lives, I get less than 1 gram. So I think like certainly 0 to 9 or 0 to 10 would be fine. I'm just going to go 0 to 10 because it's a nice round number. The minimum, since this is a decay, is 0, right? You can't end up with less than 0 grams of stuff. Everybody agree with that? You can't have negative of an amount of an element. And the maximum is my starting amount since it's a decay problem, so that's 50. Go by 5s or something. Okay, so let's hit graph. So there's my exponential decay. Whoop. That line that came in at the bottom that we couldn't really see very well is the 1 gram. Looks like it's intersecting somewhere over here, right? So second, trace. Pick the intersect command. And because I have 2 curves and 1 intersection, I don't have to worry about moving my cursor around. I can just press enter 3 times, which is all I'm going to do. Enter, enter, enter. And there's my value for t, which is 7.82. But what unit is t in? Yeah, that's a half-life. The problem asks for our answer in years. So I need to convert this back into years. And I do that by multiplying by 800. Because that's the length of one half-life. So when I do that, I get about 6,256 years. Woody, is that okay there? So the confusing part is that the t is in half-lives rather than years, right? Yeah, sure. So here we say that you invest $9,000 in an account that earns 16.7% annual interest compounded monthly. So this is a compound interest situation. So the model I need is this compound interest one. So the 9,000 is my P. The 16.7%, once I convert that to a decimal, is going to be my R. And monthly is my N. So if I write my model, I have 9,000 times 1 plus 0.167 divided by 12 to the 12t. And since this is annual interest, the t is in years, as opposed to some other function unit. Just the t is in 1 year interval, so everything is going to be very natural here on this one. There's nothing sneaky going on. So if I want the value in 10 years, all I have to do is plug 10 in for t. And when I punch that through my calculator, I get 47,262.20. Everybody okay there?
How can you get the 12 next to the 10?
Well, the n is monthly. How many months are there in a year?
Oh, okay.
12. So that's where the 12 is coming from. It's just from monthly. The n is the number of compounds per year. So monthly is 12. And then if we want, when will the account be worth $100,000? Again, we're going to just do this on our calculator. So I'm going to type my model into my first spot. So 9,000 times 1 plus 0.167 divided by 12 to the 12 times x. And then 100,000 as my other. And before I hit graph, I'm going to go ahead and set my window, because chances are if I just hit graph right away, I'm not going to be able to see much. So x is my time. So after 10 years, we got to 47,000 and change, right? exponential is going to be faster than linear. So if I double 47,000, I'm just about 100,000. That would be like a linear. The exponential should be faster than that. So I think in 20 years I'm probably good. But if you don't get an intersection when you pick that, you can just pick a bigger value, go back and pick a bigger value of x or whatever. And should be fine. But I'm quite confident that'll intersect by there. My minimum is the initial amount since this is exponential growth. And rather than doing 9,000, I'm going to write 10,000. That's just a little bit more. Or a round number anyways. And the maximum, it needs to be at least 100,000. I'm going to do 150,000 just so it's easy to see the intersection. So that it'll be in the middle-ish of my screen there. I don't know, go by 25,000 or something. Seems good.
Wait, what did you set the y minimum to?
Well, I would do the initial amount, but instead of doing 9,000, I just made it a round number.
Okay.
Because it's growth, so it can't be less than whatever you invested initially.
I just don't understand how my big calculator would know, like, how big it would be worth 100,000. Like, where do you put 100,000?
Into the other
Okay.
the other y equals spot.
Okay, thank you.
You're welcome. Megan, did you have a question? You look like you're trying to ask something.
Why did you add the 20,000?
That's just how many tick marks I'm going to have. It doesn't do anything to your picture.
It doesn't make any difference.
All it means is that like each one of these is 25,000. So like if you picked it to be 1, this would just look like a big thick black line because it's like tick marks everywhere. It just helps me estimate to like make sure I type things into my calculator correctly. I didn't make any loopers, but it doesn't affect the output count at all. Okay with that? So that's the scale. That just tells you how far apart the tick marks are. So here's my intersection, right? So second trace, intersect command, enter, 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 and 14.52, and then just years. There's no conversion needed here because my rate was annual, so it's 16% per year, so whatever t is just years. Cool with that, Woody? So this one was probably a little easier than the previous one because there wasn't anything going on with the units on t that we had to be careful about. Cal?
On worksheet 5, can you do number 10? Can you explain like all the properties as you go through it? Like what property is number 10 just like right there?
So this is an expanding problem.
Yeah.
So the first thing we look for is a quotient property.
Is that what it is? Like division quotient?
So yes. Yep. So we're looking inside the logarithm for division, and we do see division going on inside the logarithm. So the quotient property says that I should have log of the numerator minus log of the denominator. Okay with that?
Yeah.
Now, inside of each of these logarithms, we're going to look for the product property. So there we're looking for multiplication, but there's nothing being multiplied in either of those logarithms, right? So we're done with the product property. The next thing we do is we look at that same location for power properties. So we're looking for exponents. The first logarithm has no exponent, so that just would stay the same. The second logarithm, though, does have an exponent. The power property allows you to move that exponent to the coefficient, and that would be the final answer then.
Okay. That makes sense.
Okay with that?
Yeah.
So probably the easiest way to do number 1 from worksheet 6 is to try to rewrite the two exponentials so that they have the same base. Right now, one is 25 and the other is 5.
Yeah.
But hopefully it's easy to see that 25 is just 5 squared. So that's what I would do first. Now in that first exponential, we have an exponent of an exponent, right? We had a property from last chapter that says if I have an exponent of an exponent, they multiply. So that means really I have 5 to the 2 times x plus 7. And that 2 then is going to distribute through. It becomes 4x plus 14 in the exponent. So far, so good. Now, if we have two things that are equal, and their bases are equal,
Well, then you can just.
then we
cancel
know that their exponents must also be equal. Exactly right.
out. Oh. I just get confused on like how you get the bases, you know? That's where my problem is.
And then it should be easy from that point, right?
Yeah. Yeah, it's not bad. I just like confused on like how you get the bases. No, so you
Really?
could do 16 hours.
16 from the review?
Yeah, that is drop class.
Let's, do I have that problem? I don't have that page. So 16 on the review is another solving problem. For a solving problem like this, the first thing I'd want to do is to get the logarithm by itself. To do that, I would start by adding 15 to both sides. So far, so good. And then we'll divide both sides by 3. Still doing good? Now, how do I get rid of a logarithm? What cancels out a logarithm?
Another logarithm, right?
Not another logarithm. I need an exponent base. What number should I use as the base of my exponent if I have log base 5? 5. I want the base of my logarithm to match the base of my exponential. So I'm going to have a big 5, and then in the exponent, is there. Then I have a big 5, and then my exponent is the other side of the equal sign. Everybody so far so good? Those cancel. And if I go to my calculator, 5 to the 9th is whatever, 1953125. then we would add 8 over. This is one I think I have the wrong number written down here, right? I think the previous class pointed this out to me. Then I divide by 3. Yeah. This should be 651044 dot 0.33. Let's just do that real quick.
Yeah, I think that's what I got. I just got confused.
Yeah.
That's not bad. Yeah, it's just so easy. That one was really.
Sorry about that, Ray. Anybody else with questions? Megan? Oh, yes, go ahead, Rita. On the review? So 17 has the sum of 2 logs. The first thing I want to do is to isolate a single logarithm. So to do that, what I'm going to do is I'm going to condense those 2 logarithms together using, in this case, the product property because they're being added. So the product property would allow me to write this as log base 3 of x times x minus 6 equal 3. Now, what I'm going to do is, I guess at some point we have to multiply the stuff on the inside of the logarithm together. I guess let's go ahead and do that now. And then we'll cancel our logarithm. So what's going to cancel the log base 3? Exponent base 3. So I do that to both sides. So that stuff all cancels. And 3 to the third is just 27. You could type that into your calculator, or maybe you can do that in your head. I think we've done enough prime factorizations last chapter that you probably recognize 3 to the third is 27, but maybe you don't. So what we're left with now is a quadratic equation, right? To solve a quadratic equation, it has to equal 0. So I'll subtract the 27 over. And then I can either try to factor this, or I could use the quadratic formula. Since the leading coefficient is 1, I'm going to try to factor this, because if it's factorable, it should be pretty easy, and it's a little bit faster than using the quadratic formula if I can factor it. If it wasn't able to factor it, or I couldn't figure out how to factor it, again, I could just use the quadratic formula here. But this one does factor. I want to find 2 numbers that multiply to give me negative 27, and add to give me negative 6. Negative 9 and positive 3 are the 2 numbers that do that. So when I solve, I get x equals 9 and x equals negative 3. But I'm not done. For these logarithmic equations, I have to make sure that I'm checking. I guess I forgot to mention that when we did Raylan's problem because I got distracted because I knew that my answer on the key was wrong and I forgot to follow up on that. That one does check though, Raylan, so don't worry about that. If you plug it in, it does work. This one though, we do have to be a little bit careful about. So if I take 9 and plug it back into the original, all I need is to make sure the parts inside the logarithm are still positive. So when I plug 9 in for x, I have a positive number. And when I plug 9 in for x minus 6, I still get a positive number. So 9 is okay. Negative 3, though, is not. When I plug negative 3 in for x, I have negative 3. So that one's bad. So I just have the one answer here. Reader, you good with that? Somebody else was in the midst of also asking a question at that same, when Rita brought up number 17 here. But I forget who it was. Benji?
Can we do 12?
On the review?
Yeah.
I just always have to double check because we have like 6 things open. Okay. So this is a condensing problem. The order in which we do condensing problems are power, and then product, and then quotient. So to look for power properties, I'm going to look for things, coefficients, outside of the logarithm. And I see 2 of those, right? So the power property is going to allow me to move those coefficients to the exponent inside the logarithm. Next thing I'm going to do is look for product properties. So there I'm looking for addition. So I do have 2 logarithms being added together. So I can apply the product property there and move both of their insides into the same logarithm, where they're multiplied now inside that logarithm. Are you good with that, Ben? The last thing I'm going to do is look for a quotient property, which is subtraction outside of the logarithm, and we have one of those. So that's going to allow me to write this as one logarithm, where the positive part is the numerator, and the negative part is the denominator. And that would be my final answer. Sure. Megan, I thought you had your hand up. Do you have a question?
Yes. Could you do 11, please?
11. Let's see. Okay. So this is an expanding problem, so we're doing the reverse order, where we're going to start with looking for the quotient property, and we're going to be looking inside the logarithm. So I do have things divided inside the logarithm because I have the subtraction symbol. Or, I'm sorry, the division bar. So there's my quotient property, where the numerator is the first thing, and then we're subtracting the denominator. Then we look for product properties. So there is a product property going on. If I look inside the logarithms, the y to the third is being multiplied by the square root of x. So I can apply my product property here. And remember, when we were doing this, I warned you guys about this specific situation. Is what I've written here correct?
No.
What's wrong with it?
It has to be minus.
It does have to be minus. Because remember, when we use the product property, that negative
Carry.
has to carry through. Exactly right. Megan, do you remember that? Good. The last thing I'm going to do is look for power properties now. Again, we're looking inside the logarithm for the power properties. And I actually see 3 power properties. There's 2 that are obvious, the one on the z squared and the y to the third. The third one, though, is maybe not so obvious. Remember that a square root is the same thing as a 1/2 exponent. So I'm going to just rewrite the square root of x as x to the 1/2. Remember that from last chapter? Maybe you do, or maybe you don't. So the last thing I'll do then is I'll do those power properties. And there we go. there was a couple of sneaky parts to that one. You had to remember that a square root is the same thing as an exponent, or has an exponential form anyways. And then you had to make sure to distribute that negative through after you applied the product property. Al?
Can you please do number 6?
So on 6 and 7, we're just using the definition of a logarithm. So this is the definition of a logarithm. So all I need, and this is the exponential form, and this is the logarithmic form. So here, my b is 3, my x is -4, and my y is 1 over 81. So if I take that into the logarithmic form, that's log b of y is equal to x. And I think on the key I did a typo there too, didn't I?
Oh, that's not bad. Okay.
Yeah. Let's fix that real quick.
And Mr.
Yeah.
Can you show one more time, like, how to get, like, the log with the base on your calculator?
You press the math button, which is on the left hand, third from the top,
Oh, okay, I remember now.
and then scroll down to find the log base option, and you just type it in exactly the way it looks.
Okay.
No problem.